Hello everyone, my name is Nikita. I'm from EC branch. My subject is data structures and my topic is algorithm designs. What is algorithm? Algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. Algorithms are generally created independent of underlying languages. That is, an algorithm can be implemented in more than one programming language. An algorithm is a process or a set of rules required to perform calculations or some other program solving operations, especially by a computer. The formal definition of algorithm is that it contains the finite set of instructions which are being carried in a specific order to perform the specific task. It is not the complete program or code. It is just a solution or logic of a program, which can be represented either as an informal description using a flowchart. From the data structure point of view, following are some important categories of algorithm. They are searching, sorting, insert, update, and deletion. Searching algorithm to search an item in a data structure. Sorting algorithm to sort items in a certain order. Insert algorithm to insert items in a data structure. Update algorithm to update an existing item in a data structure. Delete algorithm to delete an existing item from a data structure. Characteristics of an algorithm. Not all procedures can be called an algorithm. An algorithm should have the following characteristics: unambiguous input, output, finiteness, flexibility, independent. Unambiguous. Algorithm should be clear and unambiguous. Each of its input and their inputs or outputs should be clear and must lead to only one meaning. It should have finiteness and it should mean that the instruction of an algorithm should be clear and simple. Input. An algorithm should have zero or more well defined inputs. Output. An algorithm should have one or more well defined outputs and should match the desired output. Finiteness. Algorithm must terminate after a finite number of steps. It should have finiteness. Here, finiteness means that the algorithm should contain a limited number of instructions, that is, instructions should be countable. Flexibility. Flexibility should be a flexible with the available resources. Independent. An algorithm should have step by step directions which should be independent of any programming code. Problem. A problem can be a real world or problem or any instance for the real world problem for which we need to create a program or a set of instructions. The set of instructions is known as algorithm. There are many characteristics and processing unit. The input will be given to the processing unit and the processing unit will be produce the desired output. Language independent. An algorithm must be language independent so that the instructions of in an algorithm can be implemented in any of the languages with the same output. Effectiveness. An algorithm should be effective as each instructions of an algorithm affects the overall process. How to write an algorithm? There are no well defined standards for writing algorithm. Rather it is problem and resource dependent. Algorithms are never written to support a particular programming code. As we know that all programming languages share basic code constructions like loops, do loop, for loop, and while loop, flowcharts like if and else, etc. These common constructs can be used to write an algorithm. We write algorithms in a step by step manner, but it is not always the case. Writing is a process and is executed after the problem domains is well defined. That is, we should know the problem domains for which we are designing a solution. Example. Let's try to learn algorithm writing by using an example problem. Design algorithm to add two numbers and display the result. Step 1 is start, and step 2 is declare the three integers a, b, c. Step 3, define values of a and b, and step 4 is add values of a and b. Step 5, store outputs of step 4 to c. Step 6 is print of c. Step 7 is stop. Algorithms tell the programs how to code the program. Alternately, the algorithm can be written as step 1, step add, get value of a and b, c is equals to a plus b, display c, stop. Design and analysis of algorithm. Usually, the second method is used to describe an algorithm. It makes it easy for the analyst to analyze the algorithm, ignoring all unwanted definitions. We can observe that operations are being used and how to process it flowing. Writing step numbers is optional. We design an algorithm to get a solution of a given problem. A problem can be solved in more than one way. Hence, many solution algorithms can be derived for a given problem. The next step is to analyze those proposed solution algorithms and implement the best suitable solutions. We need algorithm because of the following reasons: scalability, performance. Scalability means it helps us to understand the scalability when we have a big real world problem. We need to scale it down into small steps to easily analyze the problem. Performance. The real world is not easily broken down into small steps. If the problem can be easily broken into small steps, means that the problem is feasible. Factors of an algorithm. The following are the factors that we need to consider for designing an algorithm. Modularity. If any problem is given and we can break that problem into small modules or small steps, which is basic definition of an algorithm. It means that these features has been perfectly designed for the algorithm. Correctness. The correctness of an algorithm is defined as when the given inputs produce the desired output, which means that the algorithm has been desired algorithm. The analysis of an algorithm has been done correctly. Maintainability. Here, maintainability means that the program should be designed in a very simple, structured way so that when we redefine the algorithm, no major changes will be done in the algorithm. Functionality. It considers various logic steps to solve the real world problems. User friendly. If the algorithm is not user friendly, then the designer will not be able to explain it to the programmer. Simplicity. If an algorithm is simple, then it is easy to understand. Extensibility. If an other algorithm designers or programs wants to use your algorithm, then it should be extensible. Algorithm analysis. Efficiency of an algorithm can be analyzed at two different stages: before implementing and after implementing. They are the following: a prior analysis. This is a theoretical analysis of an algorithm. Efficiency of an algorithm is measured by assuming that all other factors, for example, process speed and constant, and have no effect on the implementation. A posterior analysis. This is an empirical analysis of an algorithm. The selected algorithm is implemented using programming language. This is then executed on target computing machine. In this analysis, actual statistics like running, timing, and space required are collected. We shall learn about the priori algorithm analysis. Algorithm analysis deals with the execution or running time of various operations involved. The running time of an operation can be defined as the number of computer instructions executed per operations. Here we can see the importance of an algorithm. Theoretical importance and practical importance. Theoretical importance. When any real world program is given to us and we break the problem into small modules, to break down the problem, we should know all the theoretical aspects. Practical importance. As we know that theory cannot be complicated without the practical implementation. So, the importance of algorithm can be considered as both theoretical and practical. Issues of an algorithm. The following are the issues that comes while designing of an algorithm. How to design algorithm? As we know that an algorithm is a step-by-step procedure to we must follow some steps to design an algorithm. How to analyze algorithm efficiency. Approaches of algorithm. The following are the approaches used after considering both the theoretical and practical importance of designing of an algorithm. Force algorithm. Brute force algorithm. The general logic structure is applied to design an algorithm. It is also known as an exhaustive search algorithm that searches all the possibilities to provide the required solution. Such algorithms are of two types: optimizing and sacrificing. Optimizing. Finding all the solutions of a problem and then take out the best solution, or if the value of the best solution is known, then it will be terminate if the best solution is known. Sacrificing. As soon as the best solution is found, then it will stop. Divide and conquer. It is a very implementation of an algorithm. It allows you to design an algorithm in a step by step variation. It breaks down the algorithm to solve the problem in different methods. It allows you to break down the problem into different methods, and valid output is produced for the valid input. This valid output is passed to some other functions. Greedy algorithm. It is an algorithm paradigm that makes an optimal choice or on each iteration with the hope of getting the best solution. It is easy to implement and has a faster execution time, but there are very rare cases in which it provides the optimal solution. Dynamic programming. It makes the algorithm more efficient by storing the intermediate results. It follows 5 steps to find the optimal solution for the problem. It breaks down the problem into a subproblem to find the optimal solution. After breaking down the problem, it finds the optimal solution out of these subproblems. Stores the result of the subproblem is known as memorization. Result reduce the result so that it cannot be recomputed for some subproblems. Finally, it computes the result of the complex program. Branch and bound algorithm. The branch and bound algorithm can be applied to any integer programming problems. This approach divides all the set of feasible solutions into smaller subsets. These subsets are further evaluated to find the best solution. A randomized algorithm. As we have seen in a regular algorithm, we have predefined inputs and required outputs. Those algorithms that have some defined set of inputs and required outputs and follow some described steps are known as deterministic algorithm. What happens that when the random variable is introduced in the randomized algorithm? In a randomized algorithm, some random bits are introduced in the algorithm and added into the input to produce the output, which is random input to produce output, which is random in nature. Randomized algorithm are simpler and efficient than the deterministic algorithm. Backtracking is an algorithmic technique that solve the problem recursively and remove the solution if it does not satisfy the problem. Algorithm complexity. Suppose X is an algorithm and N is the size of input data. The time and space used by the algorithm X are the two main factors which decides the efficiency of X. Time factor. This is measured by counting the number of keys operations such as comparisons in the sorting algorithm. Space factor. Space is a measured by counting the maximum memory space required by the algorithm. The complexity of an algorithm f of n gives the running time and or the storage space required by the algorithm in term of n as the size of input data. Space complexity. Space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cell. The space required by an algorithm is equal to the sum of the following two components: a fixed part, that is space required to store certain data, and variables that are independent of a search of the problem. For example, the simple variables and constant used program size, etc. A variable part of a space required by variables whose size dependent on the size of the problem. For example, dynamic memory allocation, recursive stack space, etc. Space complexity. S of p of an algorithm p is S of p is equal to c plus S of p of I, where c is the fixed part and S of I is the variable part of an algorithm, which depends on instance characteristics I. Following is a simple example that tries to explain the concept. Algorithm: sum of a comma b. Step 1 start. Step 2 c is equals to a plus b plus 10. Step 3 stop. Here we have three variables a, b and c, and one is constant. Hence S of p is equals to 1 plus 3. Now space depends on data type of given variable and constant types, and it will be multiplied accordingly. Time complexity. Time complexity of a algorithm represents the amount of time required by the algorithm to run to completion. Time requirements can be defined as a numerical function capital T of n, where T of n can be measured as the number of steps provided each step consumes constant time. For example, addition of two n bits integer takes n steps. Consequently, the total computational time is T of n is equals to C star n, where C is the time taken for addition of 2 bits. Hence, we observe that T of n grows linearly as the input size increasing. Algorithm analysis. The algorithm can be analyzed in two levels. That is, first is before creating the algorithm, and second is after creating the algorithm. The following are the two analyses of an algorithm: pure analysis, posterior analysis. And here are the types of algorithm, that is searching and sorting. Searching algorithm. On each day, we search for something in our day to day life. Similarly, with the same case of computer, huge data is stored in a computer that whenever the user asks for any data, then the computer searches for the data in the memory and provides the data to the user. These are mainly two techniques available to search the data in a array: linear search and the binary search. Linear search. Linear search is a very simple algorithm that starts searching for an element or a value from the beginning of an array until the required element is not found. It compares the element to be searched with all the elements in the array. If the match is found, then it returns the index of the element, else it returns -1. This algorithm can be implemented on the unsorted list. Binary search. A binary algorithm is the simplest algorithm that searches the element very quickly. It is used to search the element from the sorted list. The elements must be sorted in a sequential order or the sorted manner to be implemented the binary algorithm. Binary search cannot be implemented if the elements are stored in a random manner. It is used to find the middle element of the list. Common asymptotic notations. Constant is equals to big O of 1. Logarithmic is equals to big O of log of n. Linear is equals to big O of n. N log n is equals to big O of n log n. Quadratic big O of n square. Cubic big O of n cube. Polynomial n power 0 of 1. Exponential to the power 0 of 1. Thank you.